Sorry, it's been working the past few times, so I was like, oh, I guess he figured it out. But I will make sure I
Let's
check
see.
every
Is
time, I
this
guess.
any better? Let's check to see. Any better? Okay, I think I fixed it. I'm really bummed that we missed all of that stuff. And it's always that one setting. I don't know why I even mess with it. We need like an automated test for the stream.
Yeah, it would be nice how, some tools have like a little audio, I don't know, wave or like visual signal for your audio volume or whatever.
Well, because I'm using OBS, and so this is what I check, and I'm like, oh yeah, things are happening. That's my voice there. But the problem is that there's a fancy setting that was redirecting the audio somewhere else. I
So
wonder
it's
if
not it won't be in the
the last
recording.
stream had audio. That's funny.
I think I did check last time, or at least the time before that.
Yeah.
I've checked several times recently.
Well, Jake CX, thank you for pointing that out.
Thank you.
Definitely appreciate that. Better now than doing the whole stream without audio. And I guess I'm just gonna let everything I explain go.
Well, if it makes you feel any better, I know we did talk somewhat about the LD preload stuff last time. I mean, that was a week ago.
Yeah. But I mean, in short, again, most of what I was explaining was all the fun that I had getting it to work. But in the end, now we can run WASM files in this environment, which don't run in this emulator, but run in a worker. And they look like normal POSIX processes. And we did it with a bunch of LD preload magic stuff, but learned that we could use that bin format miscellaneous kernel feature to do pretty much the same thing. So we were talking about trying to now, like, what else would I like to get done for this preview release? And I'd like to get WASA or VS Code running in Wanix in a Wanixy way. So like I said, we've got Aptron up here, and this site is just a static site, and it was made for VS Code. It's supposed to also have a file system and a shell, so you can kind of see where Wanix kind of fits in. But then the static files, where do they come from? And wouldn't it be cool to use Wanix to be able to edit itself? So there's this idea of, well, it'd be great to get VS Code running in Wanix and using VS Code to then, do Wanixy things, possibly even, modify the code and rebuild. Because in this iteration of Wanix, we haven't really worried too much about a Go compiler or anything. Like the first version of Wanix that we have all the demos of, is a big deal because it kind of started from the idea that the Go compiler could be easily compiled to WASM and then can cross compile to any platform in the browser. Whereas this time we're focusing a little bit more on WASI, which is not Go specific, meaning, if you can use any language that compiles to WASM and WASI to create programs that would run in Wanix. And then obviously all this file system stuff. But in theory, in the last version of Wanix, we had to we didn't actually use the Go compiler. We created a custom Go compiler. Almost like a fork, practically, but not quite a fork. And so that wasn't sustainable long term, but it was the only way to get it to work in that particular environment. The hope is with WASI, and maybe if I have to do some custom stuff to make it to work, but I would like to use the actual Go compiler in Wanix to compile Go in Wanix. But we haven't gotten there yet. We'd have to finish wiring up all of WASI's standard IO stuff. There's probably some other things, but it also just isn't that important. The idea that you could compile the Wanix source code from Wanix is just kind of a nice to have, I don't want to say bragging point, but it's sort of a, just feels good to have that closed loop when that's part of the, the philosophy of all this. So at some point we'll try and get the Go compiler to work, but that doesn't have to be in the 0.3 release. But I would like to at least get VS Code running. And the idea I had is if we could produce WASM that you can run in Wanix, and then what that does is that exports a file system. So this is something that Plan 9 programs would often do. A Plan 9 program could, there was a special path called SRV, which was sort of like, it's almost like a MDNS for localhost. This is where like programs could post up a file that represents a socket to the server that it's providing. So if you run a program and it has a 9P server because it's exposing a file system as a service, it could post it to SRV. I think there's some convention where it's like the process name, the user, and then the PID or something. But then you could then open that file, and then that's basically like opening up a network connection to that service. And if it's a 9P service, then you could mount, in Plan 9, you would then mount, I think it would look something like this. In the Plan 9 case, something like, here's where the server is, and then here's where I want that file system to be mounted at. So I want processes in Wanix to be able to do something similar, which is, kind of expose or export a file system, because that's how you would, everything's through the file system. So then that's sort of the program saying, here's new stuff you can do in the system, sort of new capabilities or something. Even if that file system is just serving static files for VS Code that we can then access over the service worker, right? So in theory, we could run this binary, and then through some API we haven't made yet, it exposes a file system with the static files for VS Code to Wanix. And then we can do a bind from wherever it mounts that to wherever we want to put VS Code. So we could put VS Code at /VS Code, and then go to our service worker /VS Code, and it would load those static files from the file system, as if it was loading from the server, as if it was like Apptron or something like that. And then we'd at least have VS Code. We would still have to do the plumbing of like getting the file system and the shell to sort of then integrate with Wanix, but that's kind of a an extra step. But at that point, I would feel pretty happy, because the big thing that I wanted in the original Wanix was to run VS Code in it. And then I spent all this time getting VS Code to run in the browser to do this kind of stuff. So finally, this release will have VS Code. So to get there, we need to figure out how to do this kind of thing, where a WASI process that we run can expose a file system. And the general idea is, if it can implement a 9p server, which we have in Go, we are already using, can we somehow, because this is in the WASI environment, we don't have sockets really. So we don't have networking, but we have the file system, and that's one of the cool things about Wanix, is that everything is through the file system, and the file system is fully supported in WASI. So even though WASI doesn't support networking, we can kind of do those kinds of things through the file system. So the idea is a process that wants to share a file system runs a 9p server, and I guess instead of listening on a port on a socket like a normal server would, instead it would open a special file. Maybe it's proc export, or maybe fsys export makes sense. And so this file path would be different, for everybody, because it's basically saying this is where your process can share a 9p service. So you'd open this up, you get a socket, and then you pipe that socket into the 9p server. And by opening this file, it would cause Wanix to then kind of do something like the Plan 9 SRV thing, where it would then create a name under fsys, maybe based on the WASM file name and the process ID, so that other programs can access the file system that was exposed by this process it would be mounted here, so you could just use it. So at that point, you could then bind it to anywhere else. So the idea is you would run vscode.wasm. It would open. Can WASM sit and block while waiting on a file read? Question from chat. Yes, it depends on the environment, the WASM host. So that's one of the things that we had to kind of do to get WASI working in the browser, since WASI was not designed for the browser. It was designed for cloud environments where they're, trying to emulate Docker or something. And the WASI, which is a spec that is sort of, in development, in progress. Like right now it's WASI Preview 1, I think is the technical version. The API that the API for WASI stuff is synchronous, meaning it's supposed to be able to sit there and block and let the host runtime handle that. And so, with runtimes written in Go, yada yada, obviously that's pretty straightforward. But in the browser, to do those synchronous APIs means, it would block everything. So that's why we run it in a web worker, and we actually run it in a web worker that is allowed to block. And when you have something that's allowed to block, you're not able to handle asynchronous communication. So a web worker would have, post message and, event listener for messages. You wouldn't be able to handle the messages coming in because it's like sitting there waiting for something to complete. So the trick, which I stole from other places, is to use the shared array buffer in the browser, that you can basically get shared memory between worker processes and use that as a way to signal and communicate between the worker that is blocking. So it'll just kind of like sit there and spin and wait for the shared memory to say like, okay, here's some data, read from it. We did that a couple streams ago, I guess. So WASM can sit and block while waiting on a read. It's not really WASM that is a question for. It's more the host environment and what runtime or language is the if it's a WASM binary generated by Go, that has that built-in concurrency and can block and stuff. Got it. From the worker point of view, it blocks, but you can post a message to continue it. Yeah, we did this. We were just looking at this a little earlier in here. The WASM, the worker that we spawn to run the WASI process then spawns another worker that will actually be synchronous, and then we pass it a shared array buffer to communicate. It posts messages out because it can do that, and so we use that to find out what we need to write to the shared memory, and it's just waiting for us to say that we're done. And so that's what this set thing does, is it writes the data and signals to the other end. Is it in here? Oh man, this is gross stuff, but actually, where would it oh yeah, all this stuff. I'm using a WASI shim. This is a library that's been around for a while that kind of implements a lot of the WASI stuff for you, so that you can kind of just set up a WASI thing with here's args and environment and file descriptors. They have this whole abstraction for file descriptors and open directories, open files, and stuff like that I think that I'm sort of patching. Wanix file extends file, and it communicates over our synchronous communication mechanism. In theory, we would probably replace most of the WASI shim and write it ourselves, since I don't think this supports writes very well. But anyway, it works. To get us started. So this is kind of what I wanted to focus on today, is maybe figuring out how to get this, something like this, to work. Not prop export, but we'll just say fsys export. So a process that runs as WASI could optionally open this and provide a 9p server. This is actually kind of a weird thing, because normally when you open a file, you get a file, a read write closer. But when you're running a server and you listen, you actually, a listener is going to give you multiple read write closers as they connect. Luckily, I think only Wanix needs to talk to this 9p server. There only needs to be one connection. So when we do this open, it can basically be a pipe between the 9p server and a 9p client in the Wanix kernel that then exposes that as a mount at whatever generated name here. And then you could use that file system. So that's and what this does, it's not just for VS Code, but again, because this whole system is based on file systems, being able to create a WASI binary that runs in Wanix to provide a file system is basically being able to extend Wanix functionality, add new capabilities to it through these executables that are providing a 9p service. So of course it's more general than VS Code, but Lunan, Tara, this I guess after streaming enough, like I do have a couple of friends that check in, have watched the stream over the years.
Oh,
and
cool.
I call him Lunan because I think that was his username when we met, but Loco Juhi, I don't even remember, but pretty sure that's Lunan. Make sure I get that right.
Oh.
But yeah, how's it going? It's going pretty good. We're just trying to finish up this Wanix release. Yeah, thanks for joining. I'd ask what's up, but we're gonna try and get through a bunch of stuff today. Basic WASI. So because we'll probably test this using Go, we'll create a WASI process that exposes a 9p server. It's probably in Go, but we haven't actually used Go to create a WASI binary that runs yet. And I'm a little concerned because even with TinyGo, and even if you compile for WASI as a target, you need some special JavaScript. So it's almost like you need to do something special for Go WASI, which is not ideal. But we'll see how that goes. I guess, okay, so specific things that we're gonna do here today: basic Go WASI and 9p server. We want to build a WASI binary with Go, and get it to run. That's like the first thing. Even though we have WASI stuff, I think Go ones will need something extra. Once we have that working, we can create a 9p server. We'll just do like a dummy 9p server that just serves some in-memory file system. In fact, we can probably start that now to figure out how we would build it. So this is, let's see, where would this live? So this might eventually become our VS Code thing, but this isn't part of the project yet. It's kind of just a debug thing. So I'm putting it under local. I guess we could call it Go 9p. And I guess we just start with this. We could see if we can get this to run in Wanix. I guess we'll try it with TinyGo. It makes the most sense. But I always forget how Tiny goes. Oh, that's some cool spam. Tiny
got it.
Go. Thank you. Target WASM. I believe this means WASI. Although maybe not. Because Go you can build for WASM without it being WASI. What? It said WASI on this page? Okay. Okay, so you do use the environment variables. I guess you don't need to use, say, target. Oops. Oh, Go 9p WASM. So now we have some WASM that should say hello world. One of the things I was working on was trying to get drag and drop in here so I could like drag files to this terminal and then it would write it to this file system. Actually, I was might be able to get that done before the break because I was in the middle of it. Let's do VLAN Finder here. Let's see what this does. Okay, so I was dealing with handling the on drop on the terminal. Okay, that was, I guess, in DOM. Yeah, here's the stuff. So when you drop something on Xterm, and this is JavaScript that we're sort of driving from Go, but on the drop listener for the Xterm element, the event has files under data transfer. So we get the file. Apparently it could be multiple files, but we'll grab the first one. And then I was having trouble because this event can happen on any of the sub elements of this. And the way I organized this was the Xterm JS class. I just kind of attached onto the element. So elsewhere, you can easily get back to the terminal by just getting it off of the element. So here we go, the event target, and then to get to get the right most outermost element, it's actually on the outside of an element that's given the class terminal. So we go parent from there, and then we get term to get the Xterm JS thing. And then I'm logging both term and the file that was dropped in, and that's what this is. So this is presumably the Xterm thing. It's got an add-on manager, all this. And then here's the file that we dropped in. Okay, but it immediately panics. Invalid value. Actually, we might get better debug for this in particular if we rebuild with Big Go, which we can do. I guess with WASM Go Wanix. So this is Wanix running compiled with Big Go, and so we might get better debug stuff. Yeah, we get a better stack trace. DOM 88. So it's saying, or we're using something that seems to be a nil value. It's usually what happens. The value of, wait a minute. Open context. Handle event. Yeah, I guess it's term call. So, oh, it might be because there's this weird thing where you don't always use call. Sometimes you use get and then invoke. I don't know why, but I think I've seen that before as a cause for this, so we'll try that. Okay, no. Man, what is making it so unhappy? What I'm trying to do is use the terminal and then write to it. So basically it would, when you drop a file in here, kind of like in terminal, when you drop like a directory into that, it actually like adds the path. Same idea is kind of what I'm trying to do here. So when you drop it in, it'll actually put it into the Wanix file system and then give you a reference to it that you can then use to easily get to that file without having to like figure out where it was put. But I guess I mean, I really don't know what could be nil here. Like file and term were both, unless there's something weird about references and from Go. Let me comment this out to make sure that that is the thing that was causing it. Okay. So that's interesting. Make sure that the API exterm JS. I'm pretty sure there's just a write and write line, write data terminal. What? String you into 8 array, is that saying it could be either? optionally a callback. This does the same thing, but putting a new line. So either right or right line. And it could take a string. So let's just test writing a string. Hello. So that works. So it's not termed at the problem. That's weird. It's as if this is closer to what we want. I know it's noon, but we might be right there.
Yeah, that's fine. Just let me know when you're...
Okay, go
in
9p
later.
WASM. It wrote it to the terminal. Let's see, what was I trying to do? Oh, we wanted to. Okay, well, I guess we won't finish all this before break. We'll take a break, and then when we come back, do write the file to OPFS drop directory or something like that. And then write that path to the terminal. So this is something I wanted to get done too, because it's, even though there are a couple ways now to get files into the Wanix environment, I feel like the most convenient is just dragging stuff in.
Yeah, that'll be nice to have.
So once we do that, then we can drag in this go 9p WASM and see what happens if we try and run it. But we'll do that when we get back. Take a break for...
Well, 12:08.
5 minutes, yeah. BRB.
Mm-hmm.
Man, I'm so happy that we got the audio thing caught. Anyway, okay, I'll be back.
Yeah, that would have been bad. I'm here whenever you are.
I am here. So,
Question mark.
well, I never left. I kept working. I didn't take a break.
Oh my god. You gotta stop doing that.
Yeah.
Terrible.
Dumb. So, in order to write the file, we have to read the file. And the file comes to us as a file, which is a kind of blob.
Sorry, that does sound funny though.
Yeah. Blobs are...
Did
the
you? Are
web
you
stuff
sharing
is
your
so
screen?
weird. I should be.
I mean, maybe I need to
Oh, you
refresh my
probably need to
browser.
reload, yeah.
It's doing that bullshit again.
Yeah.
All right, sorry. Carry on.
So you're supposed to be able to read a file by using these blob methods. And this one gives us uint8 array of bytes, which is perfect. The problem is I tried to call bytes and await, and it says it's not a function, got undefined. Oh, I wonder if bytes is undefined. All right. Anyway, I also set it up to. Whoops. Uh-oh. What the hell? How does that make sense? Oh, I guess it already crashed, so it wasn't gonna handle something else. But anyway, so I made it create a global called drop file so we can investigate. So drop file bytes. We don't have bytes. I thought it was supposed to be a blob. What do we have on it? Array buffer. I guess we have array buffer, which I believe you can we do that again? Yeah. Which I believe we can put into a new uint8 array. To get a uint8 array of it. Okay, so I don't know why bytes is not available. Oh, well, that explains it. No. I am used to MDN saying like, hey, this is not well adopted yet. But maybe it's the opposite that I should assume. Because like, it explicitly says when things are widely available. I guess that's what I would look for. I don't know. It's not going to say that for everything. Array buffer. Oh, it says widely available. Anyway, I think it should be the opposite. Where, or even if it's not widely available, it says at the top, not widely available. That would be helpful. But whatever.
Yeah.
End rant. So array buffer. And we're making it's kind of obnoxious having to do this from Go this way, but JS global get uint8 array. No, not all of that. Passing result of array buffer. That should give us a uint8 array that we can then write into the file system or convert to a Go buffer. Let's make sure this works. Okay, uint8 array, there it is. So, see, we don't need this. This is the JS buffer. And look, we've done it so many times. It creates a byte array using the length of the JS buffer, then copy bytes to Go. Is that the right JS buff? Yep. So then we have a buffer. We can do fs write file. This device has a reference to the kernel, which has kind of a kludgy reference to the root namespace of the file system. Although, yeah, let's just write it like this for now. I was gonna put it in a directory, but let's just, since we'd have to make that directory, maybe we should get file name. Stop auto completing. 644.
What's a love-hate relationship with that?
With what? The auto complete? Yeah. It just, I mean, obviously it's pretty helpful most of the time, but then it's like just making noise and getting in the way. Like, what the hell is this over here? It's like some stupid thing it thinks it can do. So we're writing this file. I guess we don't actually have file permissions in OPFS, so it doesn't matter. This returns an error, so I guess, yeah, what would we do with this error? I guess write it to the console like that. Why not? So this should write the file, and then maybe what we want was oops. And then we want to write that to the terminal. Though I actually kind of hate how when you drop a file into here, it's sort of like, okay, usually maybe you're gonna use a command on it or something, so you have to remember to like write the command first. Like if it's a directory you're trying to go to, you have to remember to write cd first and then drop it in, or after it's written, control A and add cd. I think, can we control A in this terminal? I don't know. Control A. Okay, good. Well, in that case, maybe we'll just write the file name to the not with a new line. Okay. Let's drop a file in here. Oh, I I think it's because of the slash. I forget that our file systems don't use a slash at the beginning. Although what's interesting is if it writes that out, it's the Wanix path, not the Linux path. It would have to put Wanix before it, but I don't know. We'll just hard code that for now. Yeah. Okay. So, in theory, that file exists. Let's see. That's something that we could do. I can't control A now. Why not? I can't backspace either. Oh, that's weird. I can type and I can delete, but I can't go further than this data that I wrote.
What? Let's close and reopen it, I guess.
That's, well, I'm wondering why that would work. Why? Let's see. We wrote to the terminal. It should just. Maybe it's not counting that as user input. Like, I don't know how xterm.js is implemented, but maybe because that was written, it's not letting me delete it. It's probably worth asking someone who might know. What are we trying to do? Xterm.js. I guess I don't know. I thought Write would do that, but simulate keystrokes. What keystrokes? I don't know. Control sequences. I don't know. It seems like you would just write to it, so I don't know why. I can't, whatever. But anyway, what happens if I do this? Nothing. Did it even... Oh, because... yeah, because writing to the terminal isn't actually writing to the input of this shell. It's just showing us here. If that makes sense. But we'll worry about that later. The real question is, did it put it in here? And it did. Go 9p WASM. And it looks like it's the right file size. It's supposed to be WASI, so what happens if we try and run it? Okay. So this is where, yeah, I think it does assume that you have some Go specific JavaScript on the outside, which is different than all the other WASI stuff. Go.js. I wonder if it's just that we need. So normally when we run WASM from Go, we have this WASM exec file that we have to include, and it's kind of doing what that shim is doing, in that it's setting up a bunch of stuff so that when it runs the Go actually has something that kind of looks like WASI. But there's this whole system of things that I guess Go WASM binaries expect to be part of the imports. And the thing is that this is, how is this used? We use it in here. So normally we could just run the WebAssembly and the WASI stuff. Let's see, compile streaming, instantiate, splitting it in 2 lines, and then this is sort of like the imports. And so all the WASI APIs are defined by the WASI thing that we made. So that's giving, basically it's giving WASM a bunch of function definitions. And that's similar to how we do the Go stuff, where it creates the import object. So, but the thing is that this is specific to Go WASM binaries, which is really annoying. The whole point of WebAssembly and WASI is like, oh, it's a standard, doesn't matter what language. But I guess Go will have to be treated differently, or we have to explicitly support Go stuff somehow. I'm trying to think how we could merge the Go stuff. I guess it would just be if we merged this with the Go imports. And then if something isn't Go, then it can ignore the Go.js imports. I guess. Also, what's annoying is this is that file that's different depending if we use TinyGo or BigGo.
I guess at this point, it seems like we should still use BigGo for like debugging stuff.
Yeah. But yeah, and I usually go back to TinyGo as soon as possible in case something doesn't work in TinyGo. Let's see, all of this stuff. Global Go, WASI snapshot. So it's providing a WASI stuff and Go.js. So we could do import object and then merge it with the other WASI stuff, and that should overwrite this. Let's just try, well, see if all of this even, if we can just include this in this JavaScript where we have to call it. Hopefully it won't be a problem. We can test that by trying to run normal. Let's go back to TinyGo. Although TinyGo does take longer to build here. Like BigGo, this is like instantaneous.
Yeah. Wait, did you just say TinyGo takes longer to build?
Yeah.
That doesn't make any sense.
Well, it in a way it does, because Go, first of all, Go's compiler was designed to be fast, and then it also is sort of designed to be its own tool chain, so it doesn't depend on all these other compiler tool chains. Whereas the whole point of TinyGo is building Go using traditional tooling, which is both slower and more complex. So yeah, it takes a little longer, but it kind of makes sense. It's like compression, right? It's like it takes longer to compress a file to make it smaller. So I guess I look at it that way. It's like we're running compression and it takes longer. Okay, so this is running. Let's see if we can run our example RS. Like we did at the beginning. Okay, that still works for the most part. So it doesn't seem to care that this stuff is in here. Sometimes it gets picky because it's setting some global stuff, and like sometimes there's JavaScript code that looks for it detects whether it's in Node.js by looking to see if there's a global called process. But then in this context, this is setting up a global called process. So then a bunch of JavaScript that's run in the same context will think it's in Node.js. Got bit by that a few times. But anyway, that doesn't seem to be an issue here.
Wacky.
And I guess so my idea was we could do this and then use the Go import. I don't know if we need to use Go run. I guess we'll see. Maybe we can get by with just the imports. So I guess we'll do this, and how does, I always forget, object assign is a way you can merge objects, but it's such a weird function. Object assign target source, and then it returns something. So the returned output would be B4. Okay, so source is being written on top of target and then returned. So the base is the first one, because this one had B equals 2, and source has B equals 4, and the return is B equals 4. So this one's writing on top of it. Assign, let's see, object assign. Yeah, the original first, because this has a WASI snapshot preview one, but we want it to be overwritten. The autocomplete also makes me super confused at like what is actually real. It'll like suggest a comma, and I'm like, oh, there's a comma, so I'm done. And then I move away, and it's like removes the comma because it's not suggesting it anymore. And it's like, oh, it didn't actually put a comma there. Okay, I wonder if this is all we have to do, or if we're gonna have to do this as well. Kind of want to use regular Go just to have faster reloads.
Not so smitten with the TinyGo lately.
I never have been. It's always been a struggle. Like, it's not even fully complete. This whole project was sort of made possible because of a merge into TinyGo that finally made some Reflect stuff work, but not all Reflect stuff, but enough that I could get Duplex to work. So what were we doing? We're going to try and run. Let's make sure that our working WASM works like normal. Which the reason why sometimes there's this last line is because we poll for the exit code and we don't wait for standard out to finish. So sometimes it closes early and we miss some data, but we'll fix that later. So now let's try and run the Go.
Yeah, kind of important.
Yeah, there's lots of important stuff we're skipping we can come back to. Let's see what happens when we run this. Okay, that's a little surprising.
Why? Why is it surprising?
Well, first of all, there's a timeout by the service worker. That's weird. I guess that doesn't. So let's see. What is it? How does it work? When we run WebAssembly, we actually fetch it via the service worker. Like it goes through the service worker to get the WASM binary that we then put into compile streaming. So it was trying to serve this file, and for some reason took too long or something. I can't tell. Failed to execute compile because... Okay, I guess we can, find out what's going on here. That's weird. It should. Like it worked for... Where is it? This one. SW, OPFS, example RS WASM. Like, that worked fine. What's wrong with this one? What a mystery.
Yeah.
I wonder if... I've seen some bugs recently, kind of like the standard out cutting off. When you try and copy a file on the file system, it doesn't copy the whole file. Oh, I don't know why that happens, but that could be part of what's going on here.
Well, that is annoying.
Yeah, and hopefully this doesn't become a rabbit hole where we try and figure that out to get this to work. I was going to test it by doing my own fetch to get this file via the service worker and check that the bytes that I get back matches the size of the file. Service worker, OPFS, Go 9P, WASM. And then I forget. What is this? We get a response. I guess bytes. Bytes equals weight r bytes. Okay, well that's the exact size of it, so that doesn't seem to be a problem. Also, if it was fetching it like before, it complained that there was a timeout and it got a weird response code, but here when I'm doing it manually, it seems fine. I don't know if it was that like a temporary thing. We could try doing this again.
Yeah, what is that? What else would that mean, I wonder?
Okay, that's different than before. Quite a bit different. Reading exports. Oh. I think it does need a little bit more. How do we... Okay, so when we get the compiled WebAssembly, we use this Go class to run it. And apparently it's going to run it in a way that presumably makes this work based on what I'm looking at here. The problem is let's see, we get back. It's also slightly different API. This is compile streaming and then instantiate, whereas this is instantiate streaming. I think it combines those. And then it returns a WebAssembly instantiated source. Do we have that help with this? This just returns an instance. Okay, that's interesting. Pretty different API. But I guess what we pass to run is the instance anyway, so go run the instance. The problem is we're already sort of passing the instance to this WASI helper. Which is doing its own thing. So I'm trying to figure out how do I get both of these to work. That they might not work together. The source for this. Let's see, I don't have the source for it. I just have a precompiled thing. What is browser WASI shim? Start. So it's gonna do. Oh, this is pretty simple. Sets instance based on the instance that you pass it. Calls start. And I guess the way they set it up is that when you try and exit with a status code, it raises an exception. So they do this in a try catch and wait for that WASI proc exit as a way to get the status code. So basically, start blocks. It's going to run the WASM. This is an entry point for WASM _ start. And then it's supposed to return the status code. So if it runs and everything's fine, return 0 like a normal process. Or if it did exit with a particular code, it will return that. So, I don't know. We could kind of do this ourselves, maybe. What is this thing doing? Where is run? Run. So similarly, it keeps track of the instance. It's got a bunch of, it's kind of managing some Go runtime things. Then it also calls start if it has a start. Otherwise, it uses initialize, which maybe is a different entry point for something else. It looks pretty similar, except it sets up some stuff for Go. I wonder. I think that's a typo. Wait until the program exits. Let's see, and I have control over this version. Maybe I comment this out, run it through Go run so that it can do all this stuff, and then run the WASI run, which is effectively doing this. Way back up here. Okay, instance. So the idea is we can call Go run. If we could type instance. And that won't actually start it, but it will configure any of the Go stuff that needs to be set up. And then the other one will call start. So let's see if this works. OPFS. I guess we'll just try running it. Go. Blah, blah, blah. Whoa! It ran our Go program. You don't sound very excited, Tara.
Well, I think my screen was slightly behind.
Oh, yeah, you get that.
Like, figure that out.
I forget that you're a little behind. But yeah, okay, so now we have a thing that works with other WASI binaries and Go WASI binaries. Although it doesn't seem to work consistently. This is that thing we had last time. Is it because it's a big file?
How do you test that out? Can you make it smaller?
Well, the funny thing is, that makes sense. It probably exited before it read standard out. And again, and again. There we go. It's buggy in a predictable way. What were you saying? How can we? Well, TinyGo's already supposed to. Yeah, TinyGo's already supposed to make it small, but it's kind of big compared to the Rust one. I mean, less than half a meg, but
Yeah, that seems small.
I don't know. It seems hard to... Okay, there we go. So, yeah, that's interesting. I wonder if example RS WASM. I wonder if I ran example RS WASM enough times that maybe it'll happen for that one. Like it's inconsistent enough. Maybe it's not necessarily specific to the Go one.
Mm-hmm.
I mean, the other thing too is it doesn't make a ton of sense to fetch this every time because it's just copying bytes. So many bytes being copied all over the place.
Yeah.
How would this work? I guess though I did this because there's no other way to get the bytes into this worker context. I mean, other than reading from the file system, which is a little bit harder here because it's all synchronous. Once the WASI starts, so it kind of made sense to use fetch to get it. But I don't know. I guess we could make a file with a similar size. Let's see. Surely we have some probably much too large files. Like that's 23 megabytes. That's quite a bit more. Let's. We haven't been here. It's kind of crazy that these are actual programs instead of symlinked things. So it's $500K. Nothing in here. What about user bin? Zip is about similar. We all know zip. Is this really zip? Which zip? User bin zip. Zip help. Let's copy this zip to, I don't know, my desktop. And then we'll drag it in. Zip. All right, and in theory it put it there and it wrote to the terminal, but that doesn't do anything. Maybe I should just make it not do that. So now there is a zip.
Yeah.
Yeah, that's about that big. So we could try fetching it a couple of times to see if any of them fail. Ooh, look at that. So, hypothesis tested-ish. Kind of proven it, maybe? That's weird. Okay, after
So
the
it is the
timeout.
file
Oh,
size?
the timeout. Wait a minute. Okay, so it's a timeout. What am I looking for? Timeout. Service worker. So if we get this warning, SW error, timeout, it is happening here. If it's a timeout, it's actually unregistering the listener, because this was supposed to be the assumption that if you got a timeout, it was because there was nothing providing files for this thing. Like you're loading the page and Wanix hasn't loaded yet and it's trying to load stuff and it's like, oh, nothing's happening. So it times out. So then it unregistered the listener. So now I think what's happening is, because this file is, I don't know, a little larger than usual, for whatever reason, it's taking longer than a second, which seems like plenty of time, but still, it's taking longer than a second, and then it's basically failing, and then after that, it will fail because it sort of deregistered itself. So I think that's what's going on.
And it's slow because the file's big, or?
It's slow because there's probably a lot of inefficiencies right now in Wanix, copying bytes a lot to achieve, all the plumbing that we're doing. And so that has yet to be profiled and optimized. But yeah, that combined with it being a slightly bigger file and, maybe something about how I implemented something in there is slow. Anyway, point is, it's slow. That's unfortunate. Sometimes it's slow, at least. And when it's past a second slow, it will crash out and stop working. So maybe
Well, can you? What do you do for now? Like, do you increase the timeout?
Yeah, that's what I was thinking. Like, maybe that's a short-term fix.
Sorry if I stole your thunder.
No, it means your brains are in sync, which is kind of cool. But yeah, we could try 2-second timeout and just see if that works a little bit more consistently. It's not like the ideal solution, but if it helps out for now, it's a step forward.
Yeah, I guess otherwise it's like doing tedious profiling stuff.
And that stuff other people can do. Like some people love that stuff. I like it. I just don't.
It does sound kind of soothing.
Because it's like, it's a known, it's not like a creative thing. It's just like, oh, I just apply this process and, let's try doing this a couple times. Okay. So is it better at running the Go one now? There might not always be output because of the race between standard out and the exit code, but hydration time, what a good suggestion. it's also pretty much the end of the stream. So even though we're
What
not
does
getting
that even mean?
hydration time, it means drink water.
Oh. I thought it was some like coding thing.
Yeah, I know. Well, they in React they have like hydrating. I don't know. They have something called hydration.
Oh, really? Okay.
Okay, well, it eventually happened. But it mostly worked. I'm just making a lot of bugs. The thing is, bugs are quantified. It's like optimization too. It's like anybody could do it. So that's why I'm like, I don't need to spend my time doing this. Someone else can that really wants to fix it. What's the new about static website you worked on last time? Oh, they're asking you some. Go ahead.
I was just saying, yeah. I mean, as long as the Wanix is at a point where it like generally works, like some base level of.
Yeah, and I figure once we're done getting this last stuff in, it'll just be filling out issues for stuff. I've been cleaning out the Wanix issues since most of them had to do with old Wanix and aren't relevant anymore. So maybe you've been seeing some updates on that, but
Indeed, I have.
Almost closed all of them out.
The static website.
Yeah. You want to give?
Well, yeah. We set up the basic structure of like the docs and the blog and stuff. So now it's kind of in my court to work on the CSS and start filling out some of the content. And then as far as the tool itself, Jeff, what's our?
Well, if we got docs,
what do we have to say about
once
that?
we got a site and docs and we kind of proved using it to do its own site and docs, then we could cut a release. And I don't know, we still have to do a README, but all that stuff will come together. Yeah, and we can cut a release in the next couple of weeks probably. We have no urgency other than, I want to use it. There's no like.
But you are already using it, right?
Yeah, although I haven't deployed the site that I built with it yet. I've been using it to run stuff locally, but I haven't deployed it yet because I wanted to make sure it was everything that I wanted to. Who are the audience for the project? For the static site generator? Well, I don't know. Anybody that wants to generate a static site. People that, I guess this gets into the marketing of it, but we'll have to test it.
I mean, you wanted one in Go.
That's
simpler than
it's
Hugo,
written in Go.
Basically.
So like Hugo, it's faster than any other static site generator written in JavaScript because of the nature of Go being a compiled, fast systems language. But you don't have to know Go to use it like Hugo. Though Hugo, all of Hugo's templates were the Go templating. So you did actually need to know a little bit of Go to know the Go templating syntax. Whereas here, we're actually implementing, instead of having, well, I guess we have that as a fallback, but most of your page design stuff would be with JSX. So people, Rust or Go, what do you think is good? They're both good. They're both programming languages, systems languages. Obviously I prefer Go, and I don't actually like the extra work Rust makes you do to sort of achieve its claims. It feels slightly unnatural compared to programming anywhere else. That's what you got to do for memory safe programs. I guess go for it, but I don't think I want to deal with that. And I'm also a little bothered by the zealotry of the community, but Go is very chill. It's sort of like nobody cares that whether you use Go or not, it's like they Go people are sort of like, it's a good tool. Use it if you want or not. I mean, part of the zealotry for Rust is the memory safety stuff. Like they're trying to rewrite Linux in Rust because it's, more memory safe. I like Go as well. I guess we're at about time, but what were we finishing something? I forget what we were.
I think we were just
Okay, we got this working.
Up.
So we built a WASI binary with Go, and we got it to run. So the next step, which I'll probably do immediately after this stream, is to implement a 9p server and see if that runs. And then once that works, then I'll figure out how to do this export stuff. And then maybe by Monday, all this stuff will be done. And we'll be basically, I don't know, writing docs or something for this. Pretty close to the end for this. Oh, I know it's one, but here's a question. We can come back to it. You're going to sleep. Happy coding. Thank you. Nobody. Thanks for joining. So this is a design thing. So I feel like, Tara, your input will be helpful.
All right, shoot.
So the core of Wanix is about two things. We've got these processes. We've been making these. All this WASI stuff is based on this process file system or whatever /proc of Wanix, which is also tied to the file system stuff because a process gets a namespace, which is, a custom view of the file system. There's no single monolithic file system like traditional operating systems. There's the idea that you can assemble views of a file system for different processes. And so then the other core thing is file system stuff. Please don't suggest. And so these are like, we have /web and stuff, but all that's specific to the web. The core Wanix sort of abstractions there are file systems, which of course you can like bind around in different places. They could come from programs like we're trying to make happen with WASI, so that a WASI executable could provide a file system. File system could come from a network. It could come from the browser like PickRFS or OPFS. And so really it's just these two things, which to me is kind of makes sense. It's sort of the essence of the operating system abstraction. You've got processes that do stuff, and then there's a file system that provides not just data but like capabilities. The reason, so when most people hear file system, they think of storage of files. They don't necessarily think of the file system as an abstraction in the way that Linux and Plan 9 have it, where some files aren't real, they're just interfaces to something else, maybe a device driver or whatever. Like in Plan 9 and Wanix, a file. It could be anything. It's just a pipe of bytes. Maybe it makes something happen. Who knows? So file system feels like a weird way to describe file systems suddenly, because you say file system, but what people hear is not what you mean, because you mean abstract file system,
Right.
or whatever. Plan 9 never really had like a good solution to this. In fact, I think they even mentioned in the paper that was kind of a problem, was calling it a file system when people expect it to be mostly about storage of data. They called a lot of their dynamic file systems file servers. That kind of makes sense, because it's like, oh, there are things that are providing files, right?
Yeah, I don't know. Server is just kind of a
And plus, the whole
nebulous
idea
word to me.
was a lot of the time it was using 9p, which is a network protocol. So it actually sometimes is technically true that it's like a server, even though like they had built-in kernel file systems. So there isn't like a good consistent naming, because you'd say file servers, but that doesn't always mean 9p. That doesn't always mean over the network. So even though it's sometimes accurate, it still doesn't capture the whole thing.
Plus, it still has the word file in it.
Yeah, and that's, again, like people have those kinds of assumptions. So I was playing with this idea of, oh, maybe instead of file systems, we call them devices. Again, a metaphor. Instead it's like, oh, this, there's the proc device, there's the file system device, or whatever. In this case, it would be the device. I thought it's kind of a cute metaphor. It's like, it's like, makes it more of a dynamic thing. It's not just about storage. It's a thing that does something. But then there's a couple problems with that. One is that device is something that you call specific files. Like, you have a device file, like, I don't know, mouse. That's a device file. So it seems weird to call the thing that gives you a bunch of device files or whatever a device. Plus, like the short name for device is dev, at least in the Linux world. That's what /dev is. And Unix, it's short for device. And that would basically compound another problem, which is both Linux and Wanix. Let's say we went with devices, and then we also went with process. So we'd have, like, instead of fsys and proc, we'd have dev and proc. Problem is, those are already very common namespaces, directories for Linux. And, maybe that's cool because there's similar affordances. Like, oh, I've worked with the Linux proc file system. This one's similar but different. So maybe it's helpful to have that association. Device is a little bit weirder. So there's the problem of, like, somewhat incorrect analogy. It's not exactly the same thing. It's slightly different. So that could be a problem. But more importantly, if we have to run, we mount Wanix at /Wanix, and then we put you in there so that you kind of don't have to, you can kind of do things relative. But you can't get away from, because this is a Linux system, we need these things here. Like, some of these we can get rid of, but like proc is pretty much necessary for a lot of programs to work. And same for device. So if we use different names, the dev and proc, and I don't know if this is desirable, but it would mean that the Wanix directory could be mixed in with the root directory for Linux. So then you don't have this problem of like, well, when you're in Linux, you have to prefix everything with Wanix. Instead, you'd have, OPFS and web in here, which don't conflict with anything, but proc definitely will, and file system won't. But if we called them devices, that would conflict. So I'm just playing around with names. Alternative names for processes, like a process it's an abstract thing. It's very specific to like the operating system. It's sort of a unit of work, a thing that runs. But it's a general concept of like, a thing that executes, that goes, that does, which there's a couple of those, like a thread, workers, you might call them jobs in some cases, or there's a lot of things that encapsulate this idea of what a process does. And sometimes task is used. The other thing is that process, we say proc here, but in Wanix, it's not the same kind of process as a real operating system because it's more abstract. Like there's different kinds of processes. You can have a WASI process or an empty process or a native process, or like we can create different kind of process types. So in that way, it's more abstract or general than a process.
But you're still calling them processes.
But they're still called processes. So again, that's part of that is like, well, I'm torn between having this like familiar metaphor. It's like a process. In fact, you could pretty much call it a process, and it, just like a normal Unix process, it's got standard in, standard out, da-da-da-da-da. But except it's not really technically in the Wanix system. So the idea is if we give it a different name, maybe task, is something that I've been thinking about.
Well, if you call it process, I think the question that I want to know is like, does that help people understand how it works and how to use it, or is there something about that metaphor that would make it, more difficult for them to like understand how it really works or use it, practically speaking?
I don't know, especially because what we're making, I can't think of a really similar comparison. So that's why this stuff is challenging for me, and I go back and forth a lot because we don't really know. And it sucks that we would have to like put it out there and try stuff to find out. But anyway, so
Well,
go ahead.
if you call it process and they go about using Wanix in a way that they expect it to behave like processes in other operating systems, will they do things that they can't, try to do things they can't do, or do things wrong?
It's similar enough that you could say that tasks are like processes.
Then personally, I would just call it a process, but maybe you have to. Are you saying?
Okay.
Kind of sounds like
yes,
you're saying
okay.
you want to decide about task or process and device together.
Okay. Well, hold on. So there's a couple of things going on. One is, do we call proc task? And of course, one benefit is now the task file system can live in a Linux system that has a /proc. So part of it is like we can kind of put them in the same namespace, and they'll.
Yeah, I get that. I mean, if that's a priority.
I don't know that it's a
I think it
priority.
just
That's
depends on your
why
priority.
that's why it's kind of like a design discussion.
Mhm.
Plus the kind of usability and affordances of naming things. So that's one thing. But what brought this up, I mean, I think about this a lot, but what made me think about this is the name capabilities, which is kind of a stretch, but here's the
It's a big word. Also, I just want to say real quick, right before lunch, it's kind of hard to get into this like big like discussion.
I know, I know. Well,
So,
okay. Well, we don't need to finish the discussion, but I wanted to like put this out there so that you could think about it in the background or whatever. But the general idea is,
yeah.
let me do a quick pitch, is that, you know, uh, where can I do something like this? Like, what is a capability in computing? So, capability has its general sense of like, oh, capability is like a thing that can be done. But in computing, there is this security model where capability-based security is you have the thing that lets you do the thing you're allowed to do, if that makes sense.
Yeah.
Like, sometimes you have like an access token that identifies who you are, and then maybe in a central database you can find out what permissions a person has, and then you might give them a REST API, and so you can call these APIs, and it will look up the database, what you're allowed to do based on your token. Your token is more about identity than it is what capabilities you have, what your permissions are. Whereas capability-based security is you're given a thing, maybe it's an API, maybe it's a token, but that's more or less all you need to do the thing that it does. So, like, a web is kind of a hard example. Okay, an example on the web is like, instead of creating a URL that you have to authenticate with and have a access token or whatever, and you have to log in, and instead you have like a long URL that's sort of with a bunch of numbers, unguessable, and that URL is an endpoint to do the thing that you're allowed to do. So by having the URL, you have the thing that you would then call, the API endpoint. So that's kind of a capability approach on the web. The idea is, if you have the capacity to do it, or giving people permission by giving them a thing that lets you do the thing. If that makes sense. It's kind of abstract.
Okay. Yeah, no, I think it does.
Okay, really quick to
really
build on
quick.
that. Really quick. When you build a namespace in Plan 9 or Wanix, you're building a view of the file system, which isn't just files, but like in a way capabilities or functionality. The idea is that like, oh, you don't want users to be able to access the mouse. Well, you don't bind that in their namespace. You don't want them to have access to creating tasks or process or whatever. You don't put that in the namespace. So by having namespaces, that's kind of the cool thing, is that you're basically giving the processes that run in those namespaces their capabilities. What can you do? In Plan 9, there's a network device, file system, whatever, and you use that to make network connections. So to give a process the ability to make network connections is you bind that into their namespace. If you don't want them to make network connections, you don't bind it in. So the namespace design of Plan 9 is kind of a capability-based security model for your processes. You can say this process can do these things by putting them in their namespace. Hence, maybe instead of calling them file systems or devices, we call them capabilities. And again, it's more to imply the security model, but it also has connotations of doing, as opposed to just storage or files. It's actual APIs that you can use. So the crazy proposal, and then we'll end, is calling Wanix file systems, at least sometimes, capabilities. So instead of fsys, it would be cap, because unfortunately capability is too long.
It is, yeah.
And so then you have cap
Well, that
and
is certainly
task,
interesting.
and then those can live in the same namespace as a Linux system. Okay, that's it. Task and capabilities, weird, especially capabilities is kind of a stretch and a weird new thing to talk about what are basically file systems, but it could work. Maybe it's cool. I don't know. You can think about it.
Yeah, I will.
All you viewers, you can think about it. And we'll be back with more Wanix on Monday. And I guess that's it. Do we know when we're doing another TerraGen stream?
Well, I mean, I don't really want to stream like doing the CSS and the docs and stuff.
Yeah. And that's kind of all we have left. I mean, it's almost, we don't have to stream
Yeah.
that anymore now that it's done.
Yeah, maybe we don't need to.
Yeah. So that's fine. We can just do Wanix stuff until this release is done, and then we'll be done with streams for a while.
Well, you won't, I'm sure.
I mean, I'll stream, but
Yeah.
Anyway, I guess now you can eat lunch. Thanks, everybody.
Oh, thank you very much. Very kind.
Yeah. And
okay.
Bye. Is that what you're saying?
Okay, bye.
Okay,
Well,
bye.
I thought you were saying something, so
Yeah, I
just,
don't
okay,
know.
bye.
Goodbye, everybody.